All right, y'all. I can't say the song again because of copyright infringement. So we learned about inverses and we learned about exponentials. So now what we need to learn about is the inverse of exponentials. Like, how do we inverse an exponential? We got to use logs. That's why logs were developed, is to inverse exponentials. You would have dealt with this in chemistry too, right? pH levels. Okay. So, of course, they all not in agreement, world. All right, we know that log base b of n, what that tells me is b to the, oh, what's equal to? I need the p first. There it is. B to the p equals n. All right, those aren't letters I usually use. I'm going to put this over on the side of the board as a reference throughout this entire lecture. You can't see it, video world, but that's your fault. Log base b of x equals y means b to the y equals x. Your base to what's equal to equals the number you are. That's the inverse of an exponential. That's the biggest thing you guys got to know about logs. That will help us out immensely on our log journey. We're going to do so much with logs, we're going to build a house. All right. Log base b of x. So because of that, we have some special properties that occur. I cannot reiterate this enough. I'm not a big fan of memorizing things, but we're going to do this a lot. These 8 properties are going to come up a ton the rest of the unit. These should have, hold on, I need full focus here. These properties, you should have been intro to in Algebra 2. I'm going to push it. But these are going to come up huge. Every problem we're solving, we're going to use them. Now, with that being said, you probably don't have to memorize them because we're going to use them so much. But this one makes sense, right? We can develop them all. Log base b to the 1 states, for my pals in the back, I need a marker that actually works. What's this property actually saying? Like, if I didn't have this memorized, it would say b to the 0 equals 1. Does that make sense? Yeah, anything to the 0 equals. Doesn't matter what number I put in there? No. Because anything, this just says anything to the power of 0 is 1. Just like this. This is saying b to the first power equals b. B to the first power. This is your power. So like if I had log base 6 of 6, what would that be equal to? 1. 6 to what power equals 6? 1. I'll give you an example here too. What's log base 5 of 1 equal to? 5 to what power equals 1? 0. We're going to do a lot of this stuff. It'll get, now watch this. Log base b of by equals y. Because b to the y equals b to the y. This is a way to cancel out an exponent. If you're solving an equation, we're going to get to it. How do I get the exponent down? I do log, and it'll move the exponent down. Do you see how this takes it from having an exponent to not an exponent? Because it's an inverse. Do you guys like the examples? If I do log base 3 of 3 to the 4th, what's that going to be equal to? 4. Because 3 to the 4th equals 3 to the 4th. Ooh, so could you do this one actually without a calculator? Because 81 is 3 to the 4th. So if you're ever given a question like this without a calculator, you rewrite this where the base is the same as your log. And whatever power it is what it's equal to. This is a way to cancel logs. If you're stuck, if you need to get a log out of a problem and solve, which again, we're going to do a lot. I'm not expecting you to know this right now. This is the intro, and I'm going to show you how to use this to solve equations with them. Some of you guys actually, when we get into this, are going to really like this, and it's just like solving these isn't bad. You're going to do the same thing every time with most of the problems. This is a way to cancel. Because, I'm not getting into that one. Sorry, you don't get it. Should I give you an example? Sure. This is saying like 7 to the log base 7 of 3 equals 3, because those cancel. Wait a second, Mr. Twilliger. These are the same things, just for, what's an LN? It's a show that used to be on TV. LN? Alright. LN is log base E equals LN. That's called the natural log. Do you remember when we did continuous growth, we used E? This is the natural log because this is what actually occurs in nature, right? Natural, it's the opposite of Duraflame, the unnatural log. There's a fake log, so you start your fire with. So that's the natural log. You guys. So aren't these the same property? This is just saying log base E of 1 equals 0, right? These are the same. These are the same property because this is saying log base E of E equals 1. Do you guys see that? These are the same property. Same property. Same property. Same property. This one or this one? Well, I'm going to rewrite this. This is saying log base E of E to the Y equals Y. E to the log base E of X equals X. The last thing you understand why it works? Me neither, really. Actually, so no, logs are inverses of exponentials, right? So this is saying if I do log of an exponential, I get Y. It's f of f inverse of x, right? I'm plugging the inverse into the function. So this is I'm plugging my inverse. These are reverse of each other. So it's just plugging the inverse in so you get the original out. I don't care for the last one if you know how it works. I'm going to show you why we use it. Once you know where it's used, it's actually going to be a lot more straightforward. I like logs because this is actually one of the sections where I'm like, there's rules, and we just do every problem the same way with the rules. Okay? Does that sound good? This is like Algebra 3. All right. Oh, I have to say because. Do I need to grab my notes out for this? Oh, no, I can do this. I can do math. Can you guys believe it? Do you guys know why the freshman called me out and said I didn't know how to do math? Some freshman. And I'm like, well, I have a degree. He's like, then why don't you teach math? I'm not telling you. No. Yeah. He was... I defenestrated him. No. Yeah. All right. We need to give a reason. Why does log base 2 of 8 equal 3? Because, perfect, 2 to the third power equals 8. Yep. It is true. Like I said, it's always fuzzy at first. All right. Why is this one true? Because 3 to the 1/2 equals square root 3. Remember, guys, square roots are square root of x equals x to the 1/2, right? Now that's going to be a big one. That's like the third root of x equals x to the 1/3. These are just fractional exponents. I'll be honest, I wish they would just always use fractional exponents.
It says square root.
What?
It says square root.
Yeah, you could always use 1/2 power. What about this one? Does 5 to the -2 equal 1 over 25? Yeah, because remember that's what do I do with my negative exponents? They move down, right? I feel like I'm losing my voice. Newton's law of cooling. You'll see. Absolutely not. Ooh. Oh no, Mr. Twiggler. There's no number under there. If there's not a number under it, your base is 10. If there's no number, the base is 10. Because 10 is the most common. So your calculator, what log does it do? Look at your calculators. It uses base 10. So what's your base of that one? It's because it moves decimals. Log base 10 moves decimals. 10 to the first equals 10. Ooh, 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 ah. Hold on, I really gotta think. Can I do this without looking at the key? I gotta remember the proof for this. I'm gonna look at the key and make sure it's right. No, I usually just use, I am cheating. The only thing I cheat on are my taxes. Dude.
This one's on much.
Oh. That's silly. Oh, okay. Oh. I got it. No, that doesn't work either. Because it cancels. I was going to show you a way if you log both sides. No, okay. By definition, if I were to log this, right, it would say log base 6 of log. Never mind. Just get out of here. I'm not doing it. It cancels. You guys okay with that? Do you guys want to know proofs of why it works? These ones it helps, right? All right. They'll never ask you why. They won't ask you why on that one. I hope not. I hope that's your question. Write them all in exponential form. Will do. With pleasure, y'all. No, I'm doing 1 through 3. You guys can't tell me what to do because they all go together too much. I can't. Whatever. All right. Can I rewrite this as a log? So, it's log of my base, right? You always put your base there. Then I put my, what it equals there, equals my power. So you guys, does this kind of ring a bell from Algebra 2? So this one would be log base 9 of 729. That's right. Log base 2 of 1 over 32. Nothing. Log's not a number, it's a function. It's the inverse of an exponential. By definition, that's what a log is. It was created to inverse exponentials. All right, what about this one? What's my base? What did I put up here? What did I put over here? Again, this is key. And it's in the key.
So, if you do 8 times, you get half. 64.
No, 64 to the half. Square root of 64 is...
Yeah.
All right, let's do C. See, we can do 3. This is too easy. I shouldn't say that. All right, now can I go reverse? Can I go from log to exponential? Does 5 to the third equal 125? How about that? That's what the function does, actually, if you want to know what does it do. It's saying what log base 5, 125 says what power does 5 have to go to get 125?
So 5, the 1 over 125 equals 3.
No, 125 to the 1 over 3 equals 5. No, absolutely not. So 624. 625 to the 1/4 equals 5. Because that's taking the quartic root. 1/2 to the -6 is what? 64. Does that make sense? Because the negative power is going to flip it, and 2 to the 6th is, let's do one more. 2 to the -5th equals, all right. See? That's not, this is what, we're going to be dealing with logs the rest of this unit. I'm a unit. Oh, geez, Louise. I'm an academic weapon. I'm a math. Get off here. Let's end this.